Okay, I don't know what happened. I posted a video and I was doing a screen capture, and then it just kind of, the audio's there, but the video is not. So I don't know how to fix this, if I should redo the whole thing or not. But I'm going to make an update video. This is my update video. How about that? So in this update video, I'm going to show you the stuff that you couldn't see. So let's just give a quick recap. This is an analysis of the SpaceX landing. So what I did was I got the video. I'm using tracker video analysis. The first thing I did was to go down here and to move the coordinate system for each frame of the video. So just a quick overview. The idea is that if you look at the pixel location in each frame of an object, in this case I'm looking at the tip of the SpaceX Starship rocket, and if I know the scale of the system, which I know this is a 50-meter long spacecraft, then I can get position and time data by marking the location of that in each frame. Now, of course, I had to, since the camera pans, I have to account for that by moving the location of this origin right here. But I did that. I did all of that. And it's in that video, and I'll link to that down below. And again, I don't know what happened, and I apologize. I take full responsibility for everything bad that happens. So let's just go back over some of the important things we looked at. So once you do that, and this is tracker video, it's a free Java-based program. I can look at the horizontal position of the rocket as a function of time. Let's just look at this, just to do something a little bit different. So if I go down here to click Analyze, now it's going to show me. It shows me the vertical velocity on here too, because I had that last. So I'm going to turn that off. And then there's just the horizontal position. That's the horizontal position. I can fit a linear function to that, and it's fairly linear. And so this says that x is at plus b, where a is 3.04. So since this is position versus time, the slope of this linear function would be the change in x over the change in time, which is the average velocity. So in this case, the average velocity, average horizontal velocity for SpaceX during the land is fairly constant, and it's about 3 meters per second. That's fairly fast. I mean, if you want to land a rocket right at the right position, you don't want to be moving horizontally, because it's not going to work. Okay. So let's now look at the vertical position. So if I switch this to the Y position, and again, I go click on this and do Analyze. So now it's showing me that X position, which I don't really want to see. I just have that. And I have here already fit. It looks fairly linear. It's moving downwards. This is the vertical position as a function of time. It's moving vertically downward, and the slope of this linear fit is negative 3.43 E1. So this is actually 34.3 meters per second. This thing is really moving fast. It's really moving, and you want to actually stop on the ground. So you want to have an acceleration and not move at a constant speed. So is this even accelerating? It doesn't look like it. Looks fairly constant. But even at the end here, if this is a parabola even a little bit, we can measure the acceleration. So I'm going to just highlight the last section. So in that last section, now I'm going to fit a parabola to just this part. I'm going to change over here from line to parabola. And you can see there's a fit, and the end fits fairly well. But over here, I have y is a t squared plus b t plus c. And if you think about that kinematic equation, where you have 1/2 acceleration t squared, so that a parameter is 1/2 acceleration. So right here, I have negative 5.27. So I need to multiply that by 2. So this is very close to, that'd be negative 10. Okay, this is very close to negative 9.8, which is free fall acceleration. Let's get that a little. Now that's a little bit better. But you can see here that even there it's negative 3.6. Multiply that by 2 and you get 7.2 meters per second squared downward. So it's increasing in speed, moving downward. That's not how you land a rocket. Okay, that's bad. I don't know if the rocket's turned off or they thrusted down too early. I'm not sure what the problem is. All I know is this is video analysis, and this could even be there could be a mistake here. You know, I make mistakes. So, but clearly it's moving too fast and it's accelerating. Now, let me say one other thing. There was a comment already about, oh, it's not acceleration, it's deceleration. You want a deceleration. In physics, acceleration is a vector. It's the change in velocity vector divided by the change in time vector. And the direction of that vector is important. And so you could have the direction of the acceleration in the opposite direction as the velocity vector, then it would decrease the magnitude of its velocity. But it's still an acceleration. If you want to call it a deceleration, I'm cool with that. Okay, but it's still technically an acceleration. Let's look at one other thing that I did in the video. So I went over here to this Vy velocity. What this does, and I'm not sure the actual method here. Let me zoom in. It only has one thing. Oh, let's see. Analyze. Okay, so why didn't it connect the dots? I'm not sure. But you can see here that the velocity is jumping all over the place. And that's because it's taking a couple of frames and finding, based on the position, the velocity. So it doesn't give a perfect value. It's much better to find the velocity by fitting a quadratic function to the position data, because that's pretty legitimate. But again, you can see negative 34. It's around that area, going too fast. Too fast to crash. Okay, so that's a follow-up to this video, to the previous video, and I apologize. I'll have to figure out why the screen didn't record correctly the whole way. But there you go. And if everyone was like, you got to redo it, the whole thing's great, just redo the whole thing, let me know, and I'll probably do that, because I always do what people want to do. So there's that. Okay, again, sorry for the freeze. I'll make another. If you like video analysis, I'll do another one later.